In the controller area network, there are four different types of message frames, each serving a distinct function in the CAN network: the data frame, remote frame, error frame, and the overload frame. Let's begin with the data frame. The data frame is the standard CAN message and the most common message frame, and it is used to send the actual data across the bus to the other nodes. The CAN protocol defines two different standards for frame formats: the standard frame and the extended frame. So I recommend you to watch the video I made on that topic in order to understand the CAN frame structure in more detail. But in a nutshell, the extended and standard frames mainly differ in the length of the identifier, but also differ slightly in the frame structure. But in general, the data frame always starts with the start of frame bit, which is a dominant bit, and it indicates the start of transmission. After the start of frame bit comes the message identifier. Its main function is to define the priority of the message through arbitration. After the identifier, there is a RTR bit, and its function is to indicate whether the message is a data frame or a remote frame. In a data frame, the RTR bit is always dominant. After that, there is the control field, which consists of the IDE bit, reserve bits, and the data length code, which specifies the amount of data in the message. Then comes the data field, which contains the actual data that is to be transmitted. After that is the CRC field, which is 15 bits long, and its purpose is to act as a method for error detection. After that comes the CRC delimiter bit, which is always a recessive bit. After the CRC delimiter bit is the acknowledgement slot, which is used to indicate if the receiving nodes have received the message without any errors. This slot is transmitted as recessive by the transmitting node, and overridden with a dominant bit by the receiving nodes if the message has been received without errors. In case of detected errors, this field is left recessive, and the message is discarded and then retransmitted by the transmitting node. The ACK slot is followed by the ACK delimiter, which is always a recessive bit, and signals that each receiving node acknowledges the data's integrity. After that comes the end of frame field, which consists of 7 consecutive recessive bits, indicating the end of the CAN message. Now let's move on to the next frame type, which is the remote frame. The remote frame's function is to request data from another node. So if a node requires data from another node on the bus, it can request it by sending a remote frame. The remote frame structure is otherwise identical to the data frame, but the key difference is that it does not have a data field, and the RTR bit is recessive, indicating that it is a remote frame. If a node detects an error, it will transmit an error frame, which will lead to all the other nodes to send error frames too. This will cause the transmitting node to automatically retransmit the message. The error frame consists of an error flag, which is 6 consecutive bits that are of the same value, and an error delimiter, which is 8 consecutive recessive bits. The CAN bus utilizes error counters, where if the node starts sending error frames constantly again and again, the node is eventually disconnected to prevent disruptions in the bus. The overload frame is transmitted by a node if it is too busy at the current moment and needs a delay to process the current data before receiving the message. The overload frame is very similar to the error frame structure, where the overload flag consists of 6 consecutive dominant bits, and the overload delimiter consists of 8 consecutive recessive bits. The overload frame is rarely used by modern CAN controllers due to major improvements in computing speed and other factors since the implementation of the CAN protocol. But it is still a part of the CAN protocol and therefore implemented in the network.